Today we discuss about the topic AVL tree. AVL tree is a height balanced binary search tree. It is also binary search tree, but it is balanced one. How to find the balance means the difference between the height of left and the height of right subtree of every node in the tree is either -1, 0 or +1. In AVL tree, every node maintains some extra informations that is a balanced factor. Here the AVL tree can be invented by G.M. Adelson, Wellesley and E.M. Land 1962. Here the correct definition for the AVL tree is a balanced binary search tree. In a AVL tree, the balancing factor of every node is either -1, 0 or +1. How to it is a this is a definition for the balancing factor. How to find the balancing factor of each node? That is the left of height subtree minus right of subtree's value is -1, 0, 1. If it is -1, 0, 1, that tree is a balance. Otherwise, the tree is a imbalance. This is the example of AVL tree. That is the node 100. What is the balancing factor? For example, height of left subtree is 2 minus height of right subtree is, so height of left subtree is 3 and minus height of right subtree is 2, so it is equal to 1. So that node is a balance. So that's way all the node balancing factor can be checked. So if the tree is not balanced, the tree is imbalanced, so we make use some rotation. That is to make the tree is balanced, we are using some AVL tree notations. The rotation is nothing but is a process of moving node either left or right to make a tree is balanced. These are the 4 rotations used in the AVL trees. Single rotations and double rotation. Again, the single rotation can be divided into 2, left rotation, right, and double rotation can be left right rotation, right left rotations. So first one is the single left rotations. Here the every node move one position to left from the current positions. This is some example for single left rotation. For example, 1, 2, 3, each node find the balancing factor. For example, the node 1 balance factor is -1, the node 2 balance factor is -1, the node 3 balance factor is 0. So the tree is imbalanced. So that we make the tree is a balance. We are using the rotations, that is a left rotations. To make balance, we use left rotation which move nodes one position to the left. After rotation, the tree is balanced. As the next one is the for inserting value in the left side. For example, node 3, the balance factor is 2. Node 2, the balance factor is 1. Node 0, the balance factor is 0. So the tree is imbalanced. To make the balance, we use right rotations. Right rotation which move node one position to the right. So after rotation, the tree is balanced. So next, third one, left right rotations. For example, we are inserting the value left and right, the tree is imbalanced. We are using the left right rotations. We are using the 2 rotation, first one left and then 2 right rotations. This is an example of left right rotations. As the next one, third, last one, 4th rotations, right left rotations. Here the value can be inserted right and left. So the tree is imbalanced. We are using the right left rotation. First rotations, the value can be rotate left side and then right side. After rotations, the tree is balanced. This is a representation of tree. That is a here having the each node contains a 3 field. Left field, right field and data field. Left field contain the address of the left node. Right field contain the address of the right node. If the left and right no data in this leaf node, so we are using the null value. As a next one, what are the operations of AVL tree? We are using the sum operation, insertion operation, deletion operation, and choice operations. We are using what is the insertion operation? It is similar to the binary search operations, binary search tree operations. First to read the search element from the user, compare the element with the root value. If it is searching value is less than the root value, then the comparison can be done in the left side. If greater than the root value, the comparison can be done in the right side. Next one, insertion. Insert the new element in the tree using binary search tree. After insertion, to check the balancing factor of every node. If balancing factor of every node is 0 or 1 or -1, then go for the next operations. Next value can be inserted. Otherwise, to make the rotation operation using. Is some example of for constructing AVL tree by inserting number from 1 to 8. We start. First, initially the tree is empty. First, initially after 1 can be inserted. After inserting 1, to check the balancing factor 0. As a next, second value can be inserted 2. The 2 can be compared to the root value. If greater than the root value, so the 2 can be inserted in the right side. After inserting, to check the balancing factor, the first node 1. What is the balancing factor? Height of left subtree 0, height of right subtree 1. So 0 minus 1, -1. What is the balance factor of 2? Here the height of left subtree 0 and height of right subtree is 0. So it is a 0. It is similar to all the element can be inserted. For example, finally to insert the value 6, so the tree is imbalance. If make using the left rotations, that is the 4, 5, 6 to apply the rotations. So 2, 4, 5 to apply the rotations, to apply the left rotations. 2 can be move left side, and 4 act as a root, and 5 right of the root value. This is after inserting number 8. This is the final tree. Thank you.